reorganizing or we are redoing that particular same process in the software engineering. Okay. So what is software engineering? It is a systematic collection of past experience which is containing your techniques, methodologies, and guidelines. Okay. So that is what you are trying to say, but you are saying it in a different fashion. Okay. So what it is, software engineering is a collection of past experience that whatever the ancestors or whatever the software engineers used to do it earlier, that only the process we are collecting, that is the whatever the techniques they have used, that we are taking and we are trying to implement it for the further projects. We are taking all the methodologies or some of the methodologies, whatever it is necessary for the users. We are collecting all the information related to the techniques and we are taking the guidelines of each and every project or each and every aspect that is needed for us. Okay. So here engineering approach to develop software is building construction analogy. Okay. So what we are doing? We are doing the construction. Okay. So starting from the raw material collection till the last phase, that is when the house is being built, we are doing the same process for step by step process that we are doing. Okay. So this is the definition for your software engineering. It is a collection of, that is systematic collection of past experience, which includes the techniques, methodologies, and your guidelines. Okay. So where the guidelines are going to play the role, where the guidelines are going to play the role in software engineering. So when you are supposed to do a project or when you are supposed to when you're supposed to take up a project, you don't know anything. In that case, you will be taking some guidelines from so and so project and you will be going forward for the project procedures. That is collection of your raw material and all the information related to the particular project you will be gathering, and then you will be moving on to the further steps. Okay. So guidelines are useful for the users to guide us. Okay. Whatever, wherever, if you are missing anything or if something is being lost, then the guidelines are going to give us the guidance for the particular path where we are going wrong. Okay. So then here it is engineering practice. In this slide, we are speaking about the engineering practice. So whether it is happening correctly or not, that is software engineering is having three major things we have said. One is techniques, methodologies, and guidelines. So are they happening in practice really, or is it going to be on the paper itself? That is the key aspect of speaking over here as engineering practice. So is it happening regularly or only on paper it is available? So when you are going for taking up a project, you are doing it by taking the evidence or by taking the scenario of the previous project, or simply you are going with your own project. So if possible, you are taking the scenarios from the previous projects, that is wherever the modules or whatever the context is available for us, that you are capturing or that you are taking. And whenever it is not necessary for you, then you are omitting out, right? So whenever it is happening, so is it, sorry, whenever it is not happening, that is whatever the past experience that we are having, keeping in view of that particular experience, if you are moving forward, then our project is going to be well and good. So if you are not keeping our view, that is if you are not keeping anything in mind of the previous project, then your project is going to be successful or is it going to be a failure one? Most of the cases are in some cases. So you are not having any idea of your project, but you are trying to do the project, or you are trying to do whatever the executions that you want to do, and you are proceeding. You don't have any idea, you are not having any guidance, that is you are not having any guidelines to do the project. Then can you able to do the project without any mistakes? Is it possible? No, right? So most of the cases we are going to follow the previous things, that is whatever the projects that are available for us, we are going to take it as a sample copy. So say for example, if you are in second year, when you go to your final year, you will be doing your mini projects and major projects, you will be taking the sample of your seniors, and then you will be carrying forward your projects. Okay. So here also it is happening, that is engineering practices, many are just thumb rules. Okay. So whatever we are having, they are in store, that is it is available as a document, it is available in the store, it is available in the companies, or it is available in the sites or wherever we are having the information, that is Google engines or the other storage areas, we are available with the entire information. But most of the cases, it is a thumb rule. That is, it is on paper only, it is happening. But when you are practicing, you are not able to implement the same case. That is, you are not following all the guidelines, or you are not following the stipulated guidelines, methodologies, technologies that you are intended to do. Okay. So here, heavy use of past experience is systematically arranged. Okay. So you have to arrange all the views or all the cases of your previous projects in a systematic way, so that your project is going to be successful in the future, or whenever you are taking up your project, it is going to be useful for the further people, that is your uh, sorry, juniors or sub juniors, whoever is taking care of your project, as a reference that can be useful. Otherwise, it is also not going to be useful for the users. Okay. So theoretical basis and quantitative techniques are provided when you are going for the engineering practice. So theoretically, you will be having the methodologies, techniques, guidelines, and all the aspects will be available for the users. And quantitative techniques are also going to be provided. That is, n number of techniques are also going to be available for the users when you are going for the theoretical and practical point of view. But most of the cases, all are going to be in the thumb rules only. Most of the cases, all are in the thumb rules only. So then the programmatic approach to cost effectiveness is going to be there when you are going for the engineering practice. That is, when you are gathering your information, or when you are gathering your raw material, you are speaking about your cost of that particular material, which is useful for the users to take up any project and go for the further proceedings. Okay. So when we look into the technology development pattern, so how it has happened and what it is happening in the day-to-day life. So technology is increasing. You can see like this, the technology is increasing from 1950s or 1960s or past to the present. And the time is also increasing. That is, time is also moving forward, right? Then how the changes are taking place. That is, initially we used to take the past experience of the esoteric past experience, and we used to take the art reference. Then we have gone for the crafts. Then we have gone for the engineerings. Okay. So this is how the graph has progressed in the recent times, or it is going to be taken as the reference for the users, right? So then comes the question of why to study software engineering. So far we have seen, we are having some practices, or we are having some theoretical knowledge, or we are having some guidelines, we are having some techniques, we are having some methodologies that we can implement, that we can practice, that we can implement, and that we can go for the well and good construction of, well and good practice of your projects. Then why you are going for reading of this particular software engineering? Is there any necessity, or simply as it is there for us as a syllabus we are reading? Is there any use for reading the software engineering? So as you people are, most of the people are from CSC backgrounds, we require lot of things to get on and to get the job and to crack the jobs in MNCs and all the companies. We require software engineering. What it is happening in day-to-day life in industry, and what it is happening in college, and how we are taking up our projects. Okay. So when we are speaking about the software engineering, that is why to read or why to study software engineering, we are having several reasons. Okay, we are having, most of the cases we are having several reasons. So why we are studying the software engineering? To acquire skills to develop large programs. Okay, so you are very much familiar to write the programs in C, C++, Java, Oracle, or DBMS, MySQL, right? So if you are having Python, you are able to write the Python programming. If you are able to have some other kind of programming language, you could be able to write all the programming languages. Okay, so to acquire skills to develop large programs, it is necessary for reading or studying the software engineering. Okay, so when you are going to read this particular software engineering subject or software engineering, you are going to acquire the if sorry, you are going to acquire the skills to write your large programs in different languages, or you could be able to draw the pictorial representations, and you could be able to show your complete project or entire project or part of your project as the pictorial representation. That is the intention. Okay. So here exponential growth in complexity and difficulty level with size. So when you're writing or when you're trying to write the n number of lines of code, you may be facing some difficulties in writing your codes as well. So that you could be able to know when you are going to read this particular software engineering subjects. And to add, sorry, the ad hoc approach breaks down the when the size of software project increases. Okay, so whenever it is necessary, you are going to apply the software engineering as ad hoc basis. So if a question is being asked to write the sum of two programs, you are going to write the code of that particular program. Okay, so it is of maybe 5 lines, 10 lines, or 20 lines, or whatever it is, depending on your language. So if you are asked to write a coding part for complete ATM projects, then what you are going to do? You could be able to write the entire lines of code for ATM project. So if I am asking you to write the code of addition of two numbers in C, can you able to write? So if I am asking you to write the addition of two numbers in C++, you can write. So Python programming, yes, all you as you are all having Python, C, C++. So in some cases, you might be having your DBMS. So the entire code of ATM projects, that is mini balance, sorry, balance inquiry, mini statement, ATM withdraw. So all these lines of codes, that is modules of code, if I am asking you to write, so is it going to be possible? Is it going to be possible? Then what you are going to do? The entire project, you are going to divide it into pieces, that is parts you are going to do. So say for example, if you are having matrix multiplication and matrix addition, or all the arithmetic operations in a single program, what you are going to do? We are going to make it as the case 1, case 2, case 3, up to case n we are going to do, and we are going to write addition one case, subtraction one case, multiplication one case, division one case. So wherever it is necessary, wherever the problem is arising, we are going for the instant solution. Okay, so ad hoc basis, whenever it is necessary, we are going to implement the code wherever it is necessary. That particular strategy only we are going to apply, and we are going to go for the solution. Okay, so the ad hoc approach breaks down when the size of software increases. Okay, so when your program or software is increasing, ad hoc approach also is going to be broken down. That is, you are going to break your entire program into parts, and you are going to go for the solutions of each and every part. Okay, so one ton of experience is worth a whole widerness of warning. That is, when you are having a huge program and you could be able to go for the solution, that is more than enough. That is going to give us the more experience or more warnings than the uh, theoretical one. Okay, when you are going to experience a new thing, that is going to give us the new experience of how we are going to do and what we are going to do. Okay, so again we are going to go for the software engineering, so which is making us the ability to solve complex programming problems. Okay, that is, so just now we have discussed, if the ATM project, complete project is being given to us for writing the lines of code, it is difficult for us. So that is when the large programs are given, that is large programs are given to the users, we are going to make it into smaller parts, and then we are going to write the coding for that particular smaller parts of program, and then we are again merging them. So here it comes, how to break the large programs or large projects into smaller and manageable parts. That is, when you are having huge problem, how we are doing, that is how we are managing with the help of your techniques, or with the help of the guidelines, or with the help of the methodologies that are going to be seen with the help of this ability to solve complex programming problems. That is, you will be getting some idea how to do that particular problem. When you are encountering any problem, how you are going to solve the problem is going to be your solution. Okay, to learn the techniques of specification, that is, So if you are asked to write the programming part for addition of two numbers, you are writing. So if you are asked to write the balance inquiry code, you are writing, right? So that is you are identifying and you are specifically identifying what is the problem is. If you are asked to write the addition of two numbers and if you are giving the code of multiplication of two numbers, is it correct? You are asked to write the code of addition of two numbers, but you are giving the code of multiplication of two numbers. Is it going to give us the correct answer? No, right? So why? Question is something else. You are writing the answer as something else. So you have identified the question. In case where you are writing mistake code, have you identified the question? Have you identified the question? No, right? So you are giving the wrong answer. Instead of addition of numbers, you are giving some other answer. Okay. So what it is going to give us? It is going to give us, it is going to specify what is the problem is. Okay. So when you are going to read the software engineering, you could be able to specifically identify your problem and you could be able to go for the design. Okay. So you could be able to identify the problem. You could be able to go for the design wherever it is necessary, and you are going to make the interfaces. So previously what we have done, we have written all the codes for different modules and different persons. That is, code is being written by multiple number of persons. The integration part is not done. That is adding all the codes into a single module. Then only we are going to get the ATM projects, right? So in that case, what we need to do, we need to interface each and every code with one another, right? So similarly, when you are going for your projects, you have to go for the specification, you have to go for your interface, then you have to go for your development, testing, project management. So when you are going to go for testing, when you are going to go for your testing, when the code is completely available with you or when the part of code is available with you, when you are having the entire code, that is entire modules are available with you, then only you could be able to go for testing and you can go for how it is functioning for the users. Otherwise we are not going to give the complete we are not going to give us the complete result for the same projects or same task that which we have taken. Okay. So then we are going to go for project management. If you are having any errors in the entire lines of code, whatever you have written, so if you are having an error, any errors, you are going to rectify those errors. So that is the meaning of your project management in terms of your lines of code, right? So again, to acquire the skills to be a better programmer, you are going to go for the reading of this particular software engineering. So which is resulting in the higher productivity and better quality programs. Okay. So when you could be able to write the large number of programs or large size of programs, you can say that you are a good software engineer. That is big program. If you could be able to write the big programs, then you can say it as your memory is good and you are a good software engineer. Then arises the question of what is software crisis or why it is happening. So what do you mean by crisis? Crisis, downfall or improvement? Downfall or improvement in general? Downfall. Okay. So what is software crisis then? Why it is happening so? So what is software engineering? Systematic collection of your past experience, which is including techniques, methodologies, and guidelines. Okay, fine. So when you are collecting all these things and when you are doing your projects or when you are taking up your things, it nothing is going to be wrong. So when you are doing it without having knowledge or without following those things, what will be the result? So when you are having set of rules but you are not following, what it is going to result? So you are having some rules and regulations, but you're not following rules and regulations. what it will result? Good way or bad way? Bad way. So here also the same case is happening. It is leading to the software crisis with respect to the software products. Okay, so when you are having set of rules, guidelines, methodologies, techniques to be followed, but when you are not following or when you could not able to follow those things, it is happening. That is, software products are failed to meet the user requirements. So whatever the requirements that are being given by the users are not going to be met by the software products. Okay, and it is when you're delivering the project or when the project is being given to the users, it is most of the cases they are crashing. That is, so due to the inefficiency, they are leading to the crashing and all those things, and those are going to be expensive. Okay. So you're investing lot of money in your projects or lot of money in your software projects. So it is also leading to the expensive one. So it is difficult to alter, debug, and enhance your complete project or enhance your project when you are going for the software prices. That is, it is not happening. That is, when the project is being delivered, it is not going to alter, it is not going to be altered or debugged. That is, whenever you are getting any errors, you are not going to recover from those errors, and you are not going to keep that project to the further level. It is going to be diminishing, we can say. Okay, so it is often delivered late. So when you are not meeting the user's requirements, when you are not meeting the all the criteria that the user want in real term, you are not going to deliver the project to the customer within the given time. So which is leading to the late submission of your project. Okay, and it is use resources non-optimally. So the resources are also not going to be used optimally. That is, when you are having sufficient resources, but when you could not able to use all those things, then also it is leading to the software crisis. That is, the projects are failing to meet the users requirements, and frequently they are getting crashed. That is, when the users requirements are not met, the program is not going to be up to the mark, and it is going to go for the crashing, right? So it is also making the users, or it is also expensive one when you are speaking in terms of cost. And when you are having any sort of errors, it is also difficult to alter. That is, the errors are not going to be modified or rectified or not going to be removed from the code, and it is leading us to the enhancement. Sorry, it is not taking us to the further level. That is, enhancement is not happening. And when the meetings are not up to the mark, that is, when the users are expecting something and the producers are not giving it in properly manner, then we can say it as it is not delivered in proper time. Okay, so that is often delivered late. So if the timeline is given for 24 months, you will be delivering it after 24 months. If the customer is going to accept it, then only you are going to deliver it. Otherwise, you are not going to deliver it. Okay, so the use of resources are also going to be non-optimal. So if you are supposed to use only 5 limited resources, then it can lead to more than 5 resources of usability. Clear? So are we going slow or fast? Fast or slow? According to your point of view, you can judge, no issue. Are we moving bit fast or slow? Slow వెళ్తున్నారా ఫాస్ట్ వెళ్తున్నారా? ఫాస్ట్ వెళ్ళిపోతున్నామా? Okay, we will make it little bit slow. Okay. So then, so this you can see the software cost and hardware cost, how it was in 1960s and how it is in present scenario. That is up to 1991. So up to 1999. Okay. So the cost of software and hardware was very high when it was 1960s. So now it is, we are getting it for cheaper cost when we compare it with the 1960s and 1970s. Okay. So then arises the question of factors contributing to the software crisis. So what are the factors that are contributing to the software crisis? So we are saying software is diminishing or software is coming down little bit as compared with the as compared to the rest. Okay. So what are the factors that are giving the software crisis? Let us focus on those factors contributing to the software crisis. Okay. So when the software crisis is happening, when the software crisis is happening in general, you are having lot of factors over there. Lot of factors are given over here, out of which the first one is, what are the factors that are contributing to the software crisis? That is software diminish. That is when you are having large problems. So when you are having large problems, how the software is getting down? When you are having large problems, how the software is coming down or how the software is getting down beyond the expectations? So it is easy to write the small number of lines of code or big number of lines of code. Which one is easy? According to your perspective, small number of lines of code is very sufficient for us to write, to execute, to check for the errors, to modify it, and to get the final output. So when you are asked to write the Unix shell programming, Unix shell programming, is it there? Not there. So there we need to write the client side program, server side program, and we need to integrate with the IP number. Then only we could be able to get the answer. Okay, that is output in labs, we can say. Okay, so when you are having large problems, when you are having large problems, then what you are doing in general, you are making the large problems are to be divided into small number of programs or small number of problems. And again, you are going to go for the solutions for your small number of problems. Okay. So when you are getting everything correct, then it is okay. So when you are dividing your large number of programs into small number of programs and the outputs of the small number of programs are not up to the mark. That is, one team is delivering it on first day, one team is delivering it on second day, one team is delivering it on third day, right? So like this, n number of problems are being created for the large number of program or large number of problem, and all the members are not delivering the project on same day. Can you deliver the same project to the customer? So every person is delivering on different day, different day, or the deadline is given for the large program, but we are not able to deliver the same project, or we are not able to write the code for the same project, and we are unable to deliver the project. That is, we are unable to give the project to the customer. So then what it will happen? You will be writing all the agreements at the beginning, right? So the project has to be submitted on so and so date. So if it is going to fail, then you will be getting 6 months of time or 5 months of time in addition to deliver the project. All these things you are writing on paper. So what we are saying, systematic approach is there is on paper, but when it is coming to the implementation, it is not happening. So when the large programs are also available for the users, that is large problems are available for the users to write for the solution, but when you are unable to give the projects in time, or when you are unable to deliver the large problems in time, what it is happening, the software crisis is taking place. Okay, so then lack of adequate training in the software engineering. So why it is coming down? Why the large problems are not given on time, that is solutions are not provided on time? Why the solutions are not given on time? So for example, we will take these front two benches of girls, completely 12 members are available. right? So they are assigned a task of assignment, right? So 12 members are given a task of writing the assignment of software engineering for 5 questions, but they are unable to submit the 5 questions within 2 days. The task is to submit the assignment in 2 days, right? So out of 12 members, only 6 members could able to submit the assignment. What about the remaining 6 members? Will they submit? If they submit, will the assignment is going to be considered? Deadline is given for 2 days. After 2 days, they are not giving. Okay. So they are having some problem in writing their assignment, right? So if the task is assigned, they are unable to submit. If the task is assigned, they are unable to submit. Okay. So why they are failing? Why they have failed to write the assignment and submit? Why they have failed to write the assignment? So then you will be finding the reasons for why they have not submitted the assignment, right? So the reason might be they might not have the notes with them. Okay. So they are regular to the college, but they are irregular in writing the notes. That is first case. Okay. So when they are not having their notes, sufficient notes of writing the answers, can they able to submit the assignment on same time? Is it possible for them to submit the assignment on the given date? Given date, is it possible for them? They are not having any notes, or say for example, they are also irregular to the college. Okay. So if they are irregular and they are not having notes, can they submit their assignment within the given time? No. First case is no. Second case is yes. They will be copying and they will be submitting the assignment, right? So here what is lagging? They are not having notes. They are irregular to the college. That is the two options we are having. So when we are having large programs, okay, when you are having large programs, so why the program delivery is failing? So just like 12 members who are sitting in classroom, the company or where the code is going to be written, they are also humans, just like us. They are also going to write the coding part, right? So they are also having lack of knowledge of how to write the code and how to compile the code and how to execute the code. Okay. So when the small programs are given, these 12 members are very familiar with writing all the 12, all the lines of codes. So when the huge problem is given, they are unable to write because they are restricting themselves to write only 20 lines of code, 30 lines of code, 40 lines of code, or some certain amounts of lines of code only they could be able to write. So when the huge problem is given, the training part, how they have to write or what they have to write, they are missing, right? So similarly here also what it is happening, lack of adequate training in software engineering is happening, right? So how to write, what to write, when to write, and when to submit, all these things are available on paper. That is, guidelines are available on paper, but in coming to the practicality, it is not happening. That is, we are not training the software programmers in writing their code for the large number of problems or large problems. So that is also leading us to the software crisis. Okay. So increasing skill shortage. Where they are lagging? They are lagging in their skills. What are the skills that they are lagging? Maybe their technical skills, that is coding skills, debugging skills, or writing skills in some cases. Okay. So low productivity improvements are there. So which is resulting for low productivity of improvement. Okay. So when you are having huge problems, that is when you are having huge problems, they are unable to solve because they are having shortage of knowledge. So which is leading to the low productivity of improvements. So these are the factors which are contributing to the directly or indirectly for the product, software crisis. Clear? Up to here it is clear. So shall we revise once again? Up to here it is clear. Right. So what we have seen so far, so what we have seen so far, what is software engineering? That part only we have seen so far. So what is software engineering? That you are giving very good, wonderful answer. It is a systematic collection of your the experience which is having techniques, methodologies, and guidelines. Okay, fine. So then why there is a necessity for software engineering? What is happening in engineering practice? That is engineering definition we have seen. What is happening in engineering practice? What is happening in engineering practice? So we are having a number of rules, techniques, guidelines, and all those things, but they are only in on paper they are available. When it is coming for the implementation, it is not happening. Okay, so which is making us the heavy use of past experience is systematically going to be arranged, we have to do, but it is in some cases it is happening, and in most of the cases it is not happening. Right, so theoretical basis and quantitative techniques are provided for the engineering practice, and many of them are just thumb lines we are saying. Okay, so programmatic approach to cost effectiveness is happening in engineering practice. So then we have seen the technology development, how the arts, crafts, and engineering has taken place from the time to time. Right, so then we have seen why to study software engineering. Right, so we are reading the software engineering, or we are studying the software engineering to acquire skills to develop large programs. That is our first reason. So when you are reading, sorry, when you are acquiring the writing of or developing of large programs, then you could be able to give the solutions for most of the problems. Okay, so if you are giving only for small number of programs, that is small problems, then it will be becoming difficult for the users to go for the large programs. Okay, so in this process we are also going for the ad hoc approach. That is, when the huge problem is given, we are splitting it into small parts, then we are going for the individual solutions or the solutions. The second reason why we are going to go for the software engineering is the ability to solve for the complex programming problems. So when the large program is available and when it is simple, then also you are going to write the coding part. So when it is complex program, when it is difficult, then how you are going to write the programming part, that is how you are going to develop the code, is going to be tested. Okay, so that is how we are breaking your complex problem into small problem, and how you are getting the solutions for the big problem is going to be the matter when you are going to read, or when you are going to complete reading of your software engineering. Okay, so you will also learn the techniques of how to specify individual requirements for a given problem, how to design a solution for the given problem, how to go for the maintenance of interface for a given problem, how to go for the management, how to go for the development, how to go for testing, and finally how you are going for the management. All these things you will be learning after reading this particular software engineering. That is why we are reading for software engineering, and we are acquiring the skills to be a better programmer. For that reason also we are reading this particular software engineering. So then we have seen the software crisis. So what is crisis? So we can say it as the diminishing of particular software products. Okay, so the software products are failed to meet the user requirements. That is one case. They are frequently crashing. That is one case. And they are expensive. That is one case. And they are difficult to alter, debug, and enhance. That is one case. So when the programs are delivered, that is the projects are delivered late. That is also one case. And use of non-optimality is one case. So this is how it is happening with the help of cost. You can see out over here. Okay. So then we have seen the factors which are affecting the software crisis. So which includes the larger programs, lack of adequate training, and increasing skill shortage, and the low productivity of improvements. Okay, so this is what we have seen so far. So then it is programs versus software products. So when what are your programs point of view and what are your software products point of view, let us discuss. So how your programs will be in general when you are in college, program size is, so whatever the coding part that you are writing is small one or big one. Small programs only we are going to write when we are at college or whenever it is necessary for the users. So when it is compared to the software products, there we need to write the large number of programs. Okay, so the program size is small in nature, the software product size is large in nature. So then who is going to write the program? The programmer is going to write the program. So here who is the programmer? When I am writing the program, I am the programmer of my program. When you are writing the program, you are the programmer of your writing the program. Okay, so when X person is writing, X person is the programmer. When author is writing, author is the programmer. Okay, so that is here the author can be you, me, or any X person or Y person. Okay, so author himself is a sole user. So I myself is going to write the entire code. You yourself are going to write the entire code. Right. So here, when it is coming for the software projects, only one person is going to write the coding part, or multiple number of persons are going to be involved. So when you are having huge problem or large program, how many are involved? Only one is involved, or more than one is involved? More than one person is involved. So in case of software company, more number of programmers are going to be involved when you are going to write the programming part for the software products. That is, large number of users are going to be there as programmers and as the writers as well. Okay, so when you are going to write this particular program, say for example, sum of two numbers, you yourself is going to use the coding part of sum of two numbers. So when the large number of users are there, so then you are going to write the coding part for balance inquiry. Balance inquiry you are writing, or mini statement you are writing, right? And pin generation you are writing, or else whatever the requirements are there for the users for that particular part, you are writing the coding part. So who are the users for those lines of code? When you are developing an ATM project, who are the users? Who are the users? Users may be varying from time to time. Okay, so the user may be you, or the user may be external person when the project is being delivered to the user. Okay, so here it is, we are having single developer, here we are having team of developers. Okay, so when it is having, that is when it is coming for the soft own programs, that is software programs, only one developer is there, that is single developer. And when you are going for the software products, we are having multiple number of people as developers, that is team of developers we are including in the software products. Okay, so here we are having lacks of proper user interface. Okay, so here we are having well designed interface, because these persons who are writing the coding part are well trained by the so and so company. Okay, when you are writing the software products, the programmers or the coders are well designed are going to have the well designed interface, as they are well trained. Here when you are trying to write the coding part, or when you are trying to do the writing part, they are not that much trained when compared with the software products. Okay, so the lacks of proper documentation is will be there when you are going for the programs. So when you are having programs, the lacks of proper documentation, that is, you won't be having that much documentation when you are comparing with the software products. Okay, so here whatever we are writing, we are keeping it in the folder, either D drive or with your hall ticket number name. There you are keeping your programs in this system. So when it is coming to the company, they need to store the entire documentation of lines of code and what they are doing, how they are doing, and all those things they have to store. That is well documented. User manual has to be prepared by the software products. That is software products in the sense they have to go for documentation, and they have to be well structured. Documentation has to be there starting from the beginning step till the last step. And then you can go for the ad hoc development when you are writing the program. That is whenever you are having any single question, in that point of view you can go for the solution. But when you are going for the software products, you have to go for the systematic development. One step after the other step only you have to go when you are going for the software products. Are they clear? Ad hoc Ram. Ad hoc development. When you are having one question, you can directly go for that particular question and you can go for the solution. Spontaneous decision you are going to take and you are going to go for the solution. Addition of two numbers. You will write addition of two numbers. Otherwise, one question is given for writing balance inquiry. So even though we don't know the answer, you are going to stick to one particular point of view and you are going to write. But when it is going for the systematic approach, you have to go for step by step. Okay. So clear? But these differences clear. Programs versus your software products. So what is programs point of view and what is programs point of view and what is software products point of view? Is it clear? The difference. So programs is going to be small code or large code? Small code. Who is the developer? Who is the developer? Who are writing the code? They are the developers. So in cases, who is the author of the code? Who are writing the code? They are having the authorization. Okay. So do they know how to document the complete coding part when you are as a student or when you are as a programmer, when compared with the software industry, that is software product? You will be having much idea or software product team is having much idea? Software product team is having much idea of documentation, development, and all the other aspects where we are lagging little bit behind. Okay. So if you are trained, we are also going to go for the similar kind of thing. Okay. So here lacks of proper user interface is going to be there and proper documentation is available for the user side. Lagging, little bit lagging. So when we are going for the other side, so they are well designed interfaces and they are well documented people. So here we can go for the ad hoc development and here we have to go compulsory with the systematic development. Okay. So here in the sense you can go for, if a question is asked, then you can take your spontaneous decision and you can go for your implementation. So here you have to follow the set of rules and regulations and then you have to go for your solutions. This part, it is clear? Then we will see the computer system engineering. Okay. So here computer system engineering is encompassing the software engineering. Okay. So whatever the engineering process is there, that we are doing it in the computer system itself, in the recent trends and from the past few years as well. Okay. So many products require development of software as well as specific hardware to run it. Okay. So many of the cases, so starting from our coffee vending machine. Okay, so if you go to software industry or software companies, then there you can find coffee vending machines. There instead of people, the machines will give us the coffee. Okay, so here we could able to find a person is doing the entire process and giving the coffee. There you can find the complete machine is going to do the task for the users and it is going to give us the complete result. Okay. So a mobile communication products are also the examples of the products of software and hardware. Okay. So where the software is included and hardware is also included. So which is encompassing the software industry, that is software engineering. So many products require development of software as well as hardware, as specific hardware to run it. So examples we are taking it as the coffee vending machine, mobile communication product. Okay. So which is having the both the roles for software and hardware. You are writing the running notes in parallel. Finished? So here the computer system engineering is having high level problem, that is deciding which tasks are to be solved by software, which ones are by the hardware. So in previous example we have seen the question of, that is the coffee vending machine. Okay. So in coffee vending machine, which part has to be taken care by the software team, which part has to be taken care by the hardware team? It is not knowing when it is coming for the computer, that is high level problem. So when you are having a high level problem, which problem has to be decided, that is which problem or which tasks have to be solved by software and which tasks have to be solved by the hardware, are not going to be decided. Okay. So here the integration of hardware and software is going to be the key issue. Okay. So when you are doing, or when you are going for the software and hardware product, or software and hardware problems for solution, the integration part is going to play the major role. That is the combination of these two, software and hardware, is going to play the major role when you are going to go for the software and hardware problems, that is high level problems. So finally we are going to go for the testing, that is final system testing is going to be done when we are going to go for the computer systems engineering, right? So when you are going to do all these things, we are often, hardware and software are developed together. So hardware simulator is used during software development. So what we are doing, hardware simulator we are using when we are developing the software development. Clear? Last row, are you with us or you are in different? Last people, you are all here only. Yeah, you could able to follow us, or you are in somewhere else, we are in somewhere else. Sorry, you are with us. Very good. So then we will see the next one, that is computer systems engineering, how the computer systems engineering is taking place. So this is how the project management is also going to take place, that we can say. So how it is taking place, so we are going for the feasibility study. So that is, a problem is going to be identified and we are going to go for the solution by taking help of the software engineering. That is, whatever the problems that are related to our project or our topic are there, we are going to gather the entire information. That process we are going to say it as here feasibility study, right? So the entire process of collecting the information related to one topic which you are taking is your feasibility study, we can say. Okay. So when the feasibility study is done, that is, you are fixing to a particular topic, then you are going to go for the further steps of doing your project. So that further step is including the requirements analysis and specification. Okay. So when a task is taken, that is when a project is taken or a project is being assigned, you are studying what are the previous projects which are related to this particular topic. Then you are coming to a conclusion, or then you are coming to an idea of what are the requirements that I require to go for the solution of this particular project. Then you are going to go for the specifications, that is hardware partitioning or software partitioning, or both. So then you could be able to identify, if it is hardware related things you are identifying and you are keeping, if it is related to software product or software specifications, you are going to identify and you are going to develop the coding part for hardware and software. So then you are going to go for the integration, that is you are going to combine these two things and then you are going to go for the integration and testing. Okay. So you are combining the coding part and then you are going to go for the integration and testing of that particular topic. Okay. So that is, once you are choosing your topic, you are reading all the information related to that particular topic, then you are identifying what are the things that are required for doing the project that is on that particular topic. Then you are going to go for the requirement specification. So hardware and software requirement specification you are doing. Then if it is required for both, you are categorizing it into two different variations and you are doing it for software as separate, hardware as separate. That is, you are writing the code or you are developing the code for two different variations, and again you are merging those two different variations as by integrating with hardware and software. That is, integration part is taking place over here, interfaces you are developing. Then you are going for testing, that is whatever the developments that we have done with the help of software and hardware, whether they are correctly working or not, you are going to go for the testing with the help of your, in after integration you are going to go for the testing, and then you are coming to a conclusion of, if it is working properly, then you are delivering or deploying the project to the customer. Otherwise you are again going for the first phase, and where you are went wrong, again you are checking and then you are proceeding furtherly. Or else, if you are having any issues with the integration part, you are going to go for this particular part and you are going to check. So if you are having any issues over here, you are going to go over there, that is partitioning part, and you are going to check. And again, if you are finding any errors in the previous task, that is requirements analysis and gathering, there you are going to check for the requirements analysis and gathering, and then you are going to reconfirm your belongings and then you will be moving forward. So if still you are unable to identify your problems, you will be going to go for the feasibility study. So most of the cases you could be able to identify your problems in the software analysis and specifications, because your specifications are available with you and your analysis might gone wrong, right? So if your analysis is also good, but if your specifications are gone wrong, so here you, in this phase you can easily identify your problem and then you can go for the solution of hardware or software partitioning. Then you can go for further proceedings. Okay. So this is how our computer systems engineering is going to take place. So you are going to go for the feasibility study, requirements gathering and specification, that is analysis you are doing. Then you are going for the hardware partitioning. Then again you are going to split it into, if it is hardware or software, you are going to identify. If it is the mixture of both, you are going to identify, and then you are going to go for the integration. Then you are going to go for the checking, that is whether it is working properly or not, that you are going to see after your integration. So this is how the project management is going to take place in computer systems engineering. That is, our regular process is going to include these kind of steps, but the names might be different. Okay, clear? So how the systems engineering is going to take place? Clear? So those are the steps that we can say, or those are the phases that we can say when we are moving on to the SDLC, that is software development life cycle. Okay. So now let us see how the emergence of software engineering has taken place. Okay. So how the emergence has come into the existence from the past. to the present, let us see. That is from the 1960s to 2000 scenario, we will see. Okay. So early computer programmings, programs were being written in assembly language, isn't it? So previous programs, whatever we are writing or whatever the ancestors used to write, they used to write in the assembly language code. So where how many numbers are going to be used for writing the coding part? Assembly language. How many numbers were used to write? Sorry, zeros and ones were used for writing the coding part. That is assembly language programs they have used in 1950s. They have used assembly language where they have used zeros and ones. Programs were limited to about a hundreds of lines of code. Okay. So programs are also limited to some limitations, maybe hundreds of lines of code they used to write. And if you are trying to write beyond it, the systems might be crashing or something is going wrong with these systems when you are going to write the numbers of codes in beyond that limit. Okay. So every programmer developed his own style of writing programs. Okay. So if two members are there, two members are going to write the coding part in two different ways. If three number of people are there, three members are going to write the coding part in three different ways. So if m number of programs are sorry, if m number of people are there, they are going to write the coding part in their own different styles. That is, they have adopted their own style of writing code for assembly languages, but the final output is same. That is, depending on the project, the output is going to be same. So according to his intuition, that is, whatever he is thinking, that he is to write as lines of code. Okay. So then when it is coming to the 1960s, so high level languages such as Fortran, Algol, COBOL were introduced. Okay. So in 1950s, we were using assembly language programming part for writing the entire code. So to avoid such cases, that is where they are limited to some lines of codes, to avoid such things, we came to a solution called high level language such as Fortran, Algol, COBOL. So those programming languages have been introduced in 1960s, where we could be able to write more number of lines of code rather than our assembly language. So where we were restricted to few number of lines of code. So here we are getting some advantage over that assembly language writing. Okay. So this reduced software development efforts greatly. So because we are having more number of programs or more number of uh, lines of code to be written, because assembly language is giving us only limited amount of lines of code. When we are moving on to the high level language, we are getting more number of programs. So sorry, more number of lines of code are going to be written. So which is reducing the efforts of the software development. So when we were used to write the assembly language code for maybe 1,000 lines, how much time it is going to take or how much time it is going to consume? More time or less time? How much time it is going to consume when you are going to write with the help of assembly language only with zeros and ones? Sorry, more than what we were expected. Okay. So after the existence of your Fortran, Algol or COBOL, we were coming with some amount of time is being reduced. Okay. That is the time complexity or the time consuming is reduced to the great extent. Okay. So that is software development's efforts are getting good opportunities, that we can say. So that is happening in 1960s. So the software development style was still exploratory. That is, whoever wants to write the coding part, they can write the coding part in their own way. Okay, with the help of all the available languages. So typical program sizes were limited to a few thousands. So initially it was few lines of code, that is hundreds of code. So now it is increased to few thousands of lines of codes. So there it was hundreds, now it is increased to thousands. That is minimum 10 times the efforts are reduced. Okay. So whatever the coding part that the users are writing, it is reduced to 10 times nearly. Okay. So in 1960s, later part, size and the complexity of programs increased further. Okay. So the lines of codes were also increased. Same case, similar time, that is same time, the size and complexity is also increased. Okay. Size is increased, complexity is also increased. Okay. Lines of codes are increased from 100 to 1000, say for example, right? So when the thousands of lines are also increased, the complexity of the program is also increased. That is, the difficulty level also is being increased from time to time. Okay. So exploratory programming style proved to be insufficient. Okay. So that is, one person is going to write the coding part is not sufficient to satisfy the programming part for this particular complexity of problems. Okay. So when one person could able to write the complexity of program, that could be better. But it is failing us to write by thousands of lines or maybe 10,000s of lines. Okay, that is, one person could not able to write those thousands of lines. Then what is happening? Programmers found very difficult to write cost effective and correct programs. So what it is leading? So when the programmer size is decreasing, that is when the programmer size is not sufficient to write the thousands of lines of code, then what is happening? So instead of one person, we are recruiting two persons or three persons or four persons or n number of persons. So when the recruitment is growing, what it is going? The cost of giving the salary is also going with respect to software industry. So that is happening in 1960s. That is, the size was increased to 1000 lines, and betterment from assembly language to Fortran, Algol, COBOL we have included, and then we came to the program writing. There we could able to find single person is not able to write the entire coding part. There we are including or inculcating more number of people. That is also leading to the cost effectiveness. That is, as the programmers are increasing, we have to pay more money. So the cost is also increasing. So likewise, it is having difficulties as well. Okay. To overcome these things, we are coming up with the 70s one. But before 70s, we are also having some drawbacks in 1960s. Furtherly, we will see. So this part we have seen, that is, programmers found programs written by others very difficult to understand and maintain. Okay. So when one person is unable to write the coding part, what we have done, we have included more number of people. That is, instead of one person, we are including two persons or three persons, right? So everyone is writing their own coding part. So everyone's coding part is different. Everyone's ideology is different. So when it is merging together, it is difficult for understanding. Okay. So when three different people are writing with three different mindset, so what the first person is writing, what the second person is writing, what the third person is writing, that has to be understood by each and everyone, right? So that is taking lot of time. So here what they are saying, the programs written by others very difficult to understand and maintain. Okay, whatever the coding part that you have written by multiple number of people is becoming difficult to understand and difficult to maintain as well. Okay, so that is also happening in 1960s. So then they cope up with this problem. Experienced programmers advised pay particular attention to the design of the program's control structure. Okay, so what they have advised, look into the program's control structure. Okay, so what they have advised, look into the program's control structure, so that you can understand what is the problem is. Yes. Yes. You are having any break? Yes. You are having any break? Break time is there? బ్రేక్ టైం ఉందా? బ్రేక్ ఉందా? ఇప్పుడు కాదు కదమ్మా. ఇప్పుడు 11 అయింది. 12 to 1 లంచ్ బ్రేక్. ఇప్పుడు కాదు కదా. మరి బ్రేక్ టైం లాగా ఇప్పుడే సౌండ్ చేస్తున్నారు కదా. See, in another half an hour we can go for break. Meanwhile, you can concentrate, please. Okay. So much of the part we are not covering. We are focusing only on first to two topics of your syllabus as of now that you can understand. Okay. See, without PPT we can go, no problem. So 1950, what was the coding part? Sorry, what was the language that were used? Assembly language. So restricted to another half an hour we can move on. Then we can go for break. So till that time you have to face me, right? 1950s assembly language. So limited to hundreds of lines of code, right? So then came into the existence of Fortran, Algol, COBOL. All these languages came into existence and gave the solution for high level language. So where you could able to write thousands of lines. So when you are writing thousands of lines, it is not possible for a single person to write the thousands of lines. So then what we are doing, we are including more number of people for writing the lines of code. So there you are including, if you are including two number of people, that is the number is increased to two persons are writing their own language, different perspective of coding part. So if three members are writing the code, they are writing three different platforms or three different ways of writing the coding part. Then it is becoming difficult for understanding the entire coding part. Okay. So that is the problem is being faced by the most of the programmers. So what they are giving, so most of the persons are writing their own code. It is maintaining and understanding is difficult, they are saying. And to go with the solution, what they are doing, just with the just check with the program's control structure. That is, pay particular attention to the design of the program's control structure. That was the advice given by the most of the programmers. That is, how we are writing, what is the control structure that is there within the program, that you take care. Then remaining things are going to be automatically managed, that like that they are giving the solution. That is advice they are giving. Okay. So a program's control structure indicates the sequence in which the program's instructions are executed. So what is the program's control structure is giving? So it is giving the sequence. Okay. So what step is coming first? What step is coming next? What is followed by the first two steps? Likewise, n number of steps is given with the sequence. One is after the other, like that they are giving. Okay. So to help the design programs having good control structure, flow charting techniques was developed. Okay. So to go for the sequence, what they have done, they have given the flow. So that is, first step is this one. So after this, second step is this one. After this, third step is this one. After this, fourth step is this one. Like this, they have given up to n number of steps. What is the flow chart? That is, so if this condition is going to be satisfied, this second step is going to be executed. So if this is not going to be satisfied, then they are going to go for the next option. So if first and second are done, then they are going with the third step. So if here also, if something is going wrong, they are also giving the else part. That is, if condition is there, else condition is there. That is, if this is going to be the flow, they are going to go with the same sequence. If this is not going to happen, they are also going to go for the other steps. That is, flow is included with the help of your sequence. Sequence is there. To that, in addition, they are including the flow charting techniques. So that is which step or which technique has to be used before using the other steps. They are writing the coding part, or they are giving the guidelines. Clear? So here, using flow charting techniques, one can represent and design a program's control structure. That is, if you are having n number of steps, what is the step that is coming first? What is the step that is coming next? What is the step coming after these two steps is going to be given with the help of your flow chart, which you have studied in your first year. That is, flow chart and algorithm you might have studied, right? Start will be there. After that, first set of statements, then second set of statements, then third set of statements. So if something is going wrong, then you will be having other alternatives as well. So likewise, here also we are having flow charting techniques. So with the help of flow charting techniques, a program's control structure is going to be, it is going to represent the design of program's control flow structure. So usually one understands a program by mentally simulating the program's execution sequences. That is, when you are following set of rules and regulations, that is, one flowchart is being given, how it is executing. By seeing that, you can understand the program. Okay. So the flowchart is given, then how it is executing is also given. So a program having a messy flowchart representation is difficult to understand and debug. So when you are giving step by step sequence for execution, then it would be easy for the users or programmers to understand and to execute. So when you are having or when you are giving difficulty of structure, that is, so in first step you are giving something, and coming to second step, if you are giving something, third step if you are giving something else, and when you are trying to execute all these things simultaneously or one after the other, what it will happen, then it is difficult to understand and difficult to debug as well. Okay, so because the flow is missing, so you are giving set of lines, again you are mismatching, that is, you are giving multiple options. Again here you are coming and you are giving multiple options. Again here you are coming and giving multiple options. Okay, so when you are giving multiple options, it is difficult to understand and it is difficult to debug as well. That is, to rectify the errors is also difficult. Okay, so finally it was found, right? So what was found? Go to statements are useful for the solving these kinds of problems was given the solution. Okay, so later it is also went down, that is, it is also went wrong. Okay, so it was found go to statements makes control structure of programs messy. Okay, go to statements are making the control flow as messy, that is, it is making us difficult. So for example, first statement is there, so second statement is there with sequence. So what we are doing, so we are writing it as go to. So here you are writing go to. So go to so and so statement. So what it is doing, it is taking us to that statement and it is executing from there. So it is missing in between lines. Okay, so if it is necessary, then it is making the programmers to execute the program in different way. So if it is okay, then it is okay. So most of the cases, what it is doing, it is making the program as messy, that is ambiguous. Okay, so go to statements alter the flow of control arbitrarily. Okay, so what it is doing, it is controlling arbitrarily. So we are moving from first step to the one more step, that is go to statement. Whatever the go to statement is writing, there we are moving, from there we are executing. So in between things we are missing out, right? So the need to restrict the go-to statements was recognized. Okay. So at the beginning only I said. So initially it was go-to statement that was giving the solution, but later part it is also went down. Okay. So here also it is also giving us the wrong interpretations. That was the conclusion in the 1960s. So many programmers had extensively used assembly languages. So instead of assembly languages and all those things, they have used jump instructions. Okay. So jump instructions are frequently used for program branching and assembly language. So jump statements were used in assembly languages. Programmers considered use of go-to statements inevitable. That is, they are not giving us the correct outputs. So at the time, Distros published his article, go-to statement considered harmful. So what it is doing? So it is considered to be as harmful. That is, it is not giving us the correct result. Right? So when we are going to say it as harmful, when it is not producing us the correct results or whatever the expectations of the users are there, if it is not providing, then we are going to say it as the harmful one. Or else, instead of one output, if you are going to get the other output, then also we are going to say it as the harmful one. Okay. So in 1969, so Distras published go-to statement considered as harmful. Then everyone started thinking of go-to statement. So how to use it? If we are using it, what are the consequences that we are going to face? So that is, many programmers were unhappy to read his article because everyone is getting good results with the help of go-to statement. So instead of executing step by step, they are simply writing go to from first step to go to 5 or go to 4, go to 3, go to 2. They used to write and they used to execute the coding part. So when he has published this article, when it is giving us harmful effects, then everyone started hating this particular distro because they are not happy with these statements. Okay. So they published several counter articles because go to statement is giving wrong output like that Distra has published. Then all the people are going against him and they are publishing that the go to statement is very good. Okay. So they are trying to say the go to statement was very good. That is highlighting the advantage and inability of go to statement were published as counter articles to Distra again, right? So, but then later, what happened? Conclusively put, only three programming constructs are sufficient to express any programming language, right? So, for writing any programming language, only three parts are sufficient. Like that, they came to a conclusion. One is sequence, the other one is selection, the other one is iteration. So where the sequence is indicated, when you are declaring your variables, you are indicating your sequence. When if else conditions are there, you are indicating your selection. When loop statements are there, you are indicating your while loop. Okay. So sequence, selection, and iteration were given as the three programming constructs very sufficient to write your programming part, right? So this was the conclusion in the 1960s. Okay. So everyone accepted it is possible to solve any programming problem without using goto. I said at the beginning. So goto is also being denied by most of the people as article is published by Distra. Okay. So this formed the basis of structured programming methodology, right? So resulting which the structured programming methodology has come into the existence. Okay, clear? Up to here it is clear. Clear. Up to here it is clear. Control flow based design. Change your number. So after the first part, we have seen programs versus software, software products. So how the programs or program is going to be viewed, and how the software products are going to be viewed. We have seen. So how the programs are going to be, how many people are involved in writing the programs of program? Only single person. That person may be me, you, or X person or Y person. That himself is going to be said to be as the author. Then the team people are working. Then it is going to be software product. So there the documentation, designing, all the parts are going to be very good compared with the single person, because they are well trained. Okay. So then we have seen the assembly language, that is how the software engineering in the 1950s, and then we came to see 1960s. Okay. So there we have considered control flow based design is the best one, but soon it has become the other side. We are moving on to the structured programming. A structured programming is containing three different aspects. One is selection, sequence, and loops. Okay. So a program is called structured when it uses only the following types of constructs. One is sequence, selection, and iteration. Okay. A program is going to be called as a structured program when it is having selection, sequence, and iteration. So the sequence has to be there, selection has to be there, and the structure, that is iteration, has to be there. So in those cases only we are going to say it as the structured program, right? So unstructured control flows are avoided because we are giving the sequence, we are giving the selection, we are giving the iteration, right? So by giving all those things, we are avoiding the unstructured control flow, right? So it consists of a neat set of modules. So when you are speaking about the structured programming, that is structured programs, you are having are consisting of set of modules, because you are having all the constraints of three, that is sequence, selection, and iteration. You are having 3 points you are having. So use single entry, single exit program constraints, right? So a structured program is having single entry point, that is starting from one end, and ending is also there at the other end. Okay. So because it is having the sequence, then selection, and then you are having iteration. Okay. So you are declaring your variables, you are writing your coding part. So if it is necessary, you are iterating and you are executing your program, and completely compulsory you are writing your outputs when you are writing your structured program. So when you are going for unstructured program, the control flows are avoided because you are not giving any sequence, structure, or any iteration part, right? So however, violations to this feature are permitted. Okay. So you are giving three aspects. One is selection, sequence, selection, and iteration. So these are not mandatory in everyone's program. Okay. So that limitations are also provided. Okay. That is violations to these things are also provided. Okay. So due to practical considerations such as premature loop exit to support. So in some cases, before the completion of the loop only we are executing or we are exiting from the loop. So due to those reasons, they are having exception handling. Okay. So these concepts we are seeing in the Java programming. Okay. So these are also not mandatorily there. So they can also be avoided. The condition is the loop exit support exemption handling. So whenever it is there, then you are going to avoid these three steps as well. Okay. So structured programs are easier to read and understand, easier to maintain, requires less effort and time for development, because you are giving the structure, you are giving the selection, you are giving the iterations. So when everything is provided, it is easy for the users to understand, it is easy for the users to maintain, it is easy for the users to develop, and it is easy for the users to test and debug as well. Okay. So when everything is making easy, then it is easier. That is, structured programs are easier to read, understand, maintain, requires less efforts and time for development, because everything is predefined. So you have to write according to that particular syntax or according to that particular structure itself. Okay. So coming to the research experience. So the research experience shows programmers commit less number of errors. Why? Why the programmers are committing less number of errors in structured programming? When you are having structured program, why the errors are reduced? Why the errors are reduced? So when you are having structured programming, how many points you are keeping in view? 3 points you are keeping in view. What are those 3 points? Selection, sequence, and iteration. So these 3 points for any problem are defined, predefined already. So what it is making? So if sequence is missing, you may be getting the errors in your selection. So if you are getting selection errors, you may be getting your output errors. That is your iterations. Flow might be missing. So what it is indicating? So it is indicated clearly. Programmers commit less number of errors while using structured if then else and do while statement compared to test and branch constructs, because the structure is already fixed. We are writing according to the structure. So when you are writing according to your structure, that is while using your structured if then and do while statements, you are writing or committing to less number of errors when compared with the remaining aspects. Okay. So research experience also showing that programmers are committing to the less number of errors due to the series, that is sequence. Okay. That is, following those 3 points, they are making less number of errors. Okay. So then came into the existence of data structured oriented design in 1970s. Okay. So soon it was discovered it is important to pay more attention to the design of data structures of the program than to the design of control structure. So control structure we have designed. So it is important to design structure, they are saying. Okay. So taking care of the design of data structure is more important than the control structure, was the conclusion or was the beginning aim for the 1970s. So far we have seen the control structure. The control structure is including three parts. So that is sufficient for the program writing. That what was the conclusion from the 1960s. But later it came into the existence of 1970s. Design of data structures of a program is also important, rather than including the control structure was the conclusion or the beginning statement, right? So techniques which emphasize designing the data structure or deriving the program structure from the called as data structure oriented design scenarios or design techniques, right? So techniques or technologies. Okay. So derive program structure from it. So what it is going to design? So it is going to design the techniques which emphasize the designing the data structure. Data structure designing is going to be taken care. Okay. So are called data structure oriented design techniques. Okay. So example of data structure oriented design techniques includes Jackson structures programming. That is JSP we can say, JSP programming. Okay, so developed by Michael Jackson in 1970s. Okay, so JSP was developed in 1970s by Michael Jackson to overcome the problems in 1960s. That is, flow-oriented structure is kept aside and design-oriented structure is came into existence from 1970s. So JSP techniques, program code structure should correspond to the data structure. So whatever the coding part that you are writing, that code structure should correspond to your data structure, what you are intended to design. So in JSP methodology, a program's data structures are first designed using notations, that is sequences, selections, and iterations again. So then data structure design is used to derive the program structure. Okay, first you will be developing with the help of your flow structure, then you will be going for your data structure design. Okay, so several other data structures oriented methodologies also exist. Examples include your Warnier or methodology, some of the example. Okay, so then came into the existence of your data flow design. So previously we have seen our control flow. So now we are coming to the data flow. Okay, so data flow oriented techniques are advocate the data items input to a system must first be identified. So what are the inputs that have to be identified? Then you have to go for the proceedings. Okay, so processing required on the data items to produce the required output should be determined. So you need to identify the inputs. So based on the inputs, what you are getting as output, that also you should be identified. So data flow technique identifies the different processing stations or functions in a system. Okay, so these items that flow between processing stations. Okay, processing stations here in the sense one step to the other step you can understand. So data flow technique is generic technique, can be used to model the working of any system. Okay, so DFD we can say it as DFT, data flow technique, right? So which is giving us how the data is flow from one step to the other step or one module to the other module, that is going to be tested with the help of DFT, right? So not just software systems. Okay, so a major advantage of data flow technique is its simplicity, right? So how the data is flowing from one module to the other module is going to be tested with the help of your data flow techniques. Okay, so it is very simple in nature for the users, that users can easily understand what the flow structure is going to give us for the users. That is what we are going to follow from first step to the second step, second to the third, third to the further steps. So data flow diagrams are going to be indicated. Okay. So a data flow model of a car assembly unit is given like this. So how the data flow is going to be? So first you will be going for engine store, then you will be fitting the engine, then you will be storing your chassis number, that is chassis store you will be storing, then you will be fitting your doors, then you will be you will be collecting doors from your door store, then you will be fitting your doors, then you will be moving on to the fitting wheels. From wheel store you are collecting all your wheels and you are fitting there, and then you will be going for the paint and test, that is what is the color that the car should be having and how the car should run. Okay, so this is how the data flow model of a car is. Okay, that is starting from which step we are moving on to which step is indicated with the help of data flow diagrams. That is how the flow has to be. What is the first step? So first step here, what we are doing, we are going to the engine store and we are taking the engine from there. Then we are going for fitting that engine into the car. Okay, so again we are moving on to the chassis store and we are taking the chassis number of this car and we are writing the chassis number over there, right? So here both will be getting from only one end, but the diagrammatic part we are representing as different. Okay, so then we are moving on to the doors. So once the engine is fixed for the car, we are moving on to the doors and we are fixing the doors to the car. So here we are moving on to the door store and taking the doors. Again, we are fixing the doors for the car. Then we are fixing the wheels by visiting the wheel store. We are collecting all the four wheels or six wheels or whatever the wheels that we are in it. We are collecting those wheels. We are fixing those wheels, and then we are compulsorily finally we are painting. That is, what is the color of that particular car has to be that we are seeing, and then we are going for the paint and test. That is, we are running the car and we are testing the whether it is correctly working or not. Right. So this is how the car flow, that is data flow diagram of car structure is going to be. Clear? Data flow diagram. Right. So then we came into the 1980s with the object oriented design. Right. So what do you mean by object oriented design? Oops, you're having the subject. Oops or oops through Java, oops through C++. Right. Then what do you mean by object oriented? Object oriented or objects. So here you are having object oriented technique, right? So which is having an intuitively approaching design approach. So which is giving us the natural objects such as employees, payroll, registers, etc. occurring in a problem are first identified, right? So bench we can say it as an object, right? So collection of objects we can say it as the class. So after the completion of control flow structure, we came to the data flow structure. Then we are coming to the object oriented structure. So first it was assembly, then it was control flow, then it was data flow. Now it is coming to the object oriented design and object oriented flow. Okay. So this is what happened from over the years to 1980s only. Still we are not reached up to 1990s. So we have seen up to 1950s, 1960s, 1970s, and now we are moving on to the 1980s. So in 1950s, what were used? 1950s. Just we can recap and we can move on to the break. Okay. What were used in 1950s? 50s, 50s. 50s. 50s was assembly language. Next, 50s. Were there any problems? Any problems were there? So limited to hundreds of lines. Okay. And one person is going to write hundreds of lines. They are restricted. Two persons are going to write different codes, but they were taking more number of time. So 1960s, high level languages were introduced like COBOL, Fortran, and Algol, and they have given the permission up to thousands of lines. So when thousands of lines are written by multiple number of people, what it was happening? Understanding was difficult. Okay, so the understanding was difficult, but the limitations were thousands only. So understanding was difficult. Then what was the solution for the understanding? So if everyone is writing their own code, the understanding was difficult in 1960s, right? So that is control flow based design was giving us difficulty. Then came into the existence of what were the conclusions? Control flow design is having some issues. Then what was this solution? Control structure. That is, programs control structure has to be taken care. That was the solution given, right? So when the solution was given, so flow charting technique came into the existence. Okay, control flow design was completed, then came into the existence of flow charting structures. So when the flow charting structures was used, they were also having some difficulties. Okay. So when they were also having some difficulties, that is, it is difficult to understand. That is, there is an ambiguity in go to statements and all those things we have found. So then came into the existence of few articles opposing go to statements. So Distra has written an article on go to statement which is giving us harmful effects in 1969. So in order to oppose him, most of the people have written the same articles against him. That is, go to statement is good and the other statements are also giving the solutions. So to avoid those things, what they have found the solution, they have given the solution as three things: selection, sequence, selection, and iteration. So then also they were not happy with these three sequence of steps, as these are also leading to the huge problems in the difficulty level. So then they have gone for the structured programming structure. Okay. So in structured programming structure, what they have given, they have provided three aspects like sequence, selection, and iteration. And in addition to that, they have also providing modules, flow charts, data flow diagrams, data flow techniques to avoid those difficulties. Okay, they are also including and they are also giving exemptions for those three aspects with respect to some loops. Okay, so then it is giving. So structured programs are very easy to understand, maintain, write, design, test, everything is fine. Like that, they are writing the code. But later part, what they are doing, they are also giving some drawbacks or difficulties like that they are saying. So then coming to the existence of your data structured oriented design. So where we are seeing our data structure oriented design as JSPs. JSPs are also giving some difficulties like that they are saying, and then they are moving on to the data flow oriented techniques. They are also having some drawbacks like that they are saying, and then they are moving on to the object oriented programs. Okay, so this is what the history is saying about software engineering. Okay, so far we have covered only one to two topics according to your syllabus. Okay, right? So this is what we have seen so far. So if possible in the afternoon class, we can conclude our first half of your syllabus. Okay. So still we are in second topic or third topic of your syllabus. According to your topic, still we are in second or third topic only. Okay. So if you could able to make little bit fast in the afternoon session, we could be able to complete at least the first part. Okay. So I understood that this is a lengthy syllabus, but still we could able to manage. If possible, we could able to complete up to the we could able to complete up to the first part at least. So if it is done, then we can go for our remaining parts. Okay, right, Rama. Okay, no issue. We can cover up to the first part and we can move on also to the second part. No issue. Okay. So as most of the slides are covered, so still we are having few more slides only to cover. So we can cover up to those things and we can go for the second part as well. Okay. Break time, enough. Okay. So you can move on to your lunch time. Gather here by the time, within time. Okay. On 22, Rama, reckless. On 22, 23.